Good afternoon. I'm Amanda Brock. I'm the CEO at Open UK, and we're the industry organisation for the business of open technology. That's open source software, open hardware, and open data. And it's a great pleasure to welcome you today to join us in our 8th episode of this first season of State of Open Subset, our digital follow-up to State of OpenCon. Today is the first time we're having a duet, 2 speakers in a duo, and I'm delighted to welcome Hannah Foxwell, Product Director at Snake, and Adrian Mouat, Technical Community Advocate at ChainGuard. And they're going to talk to you today about getting started with container security, a topic that very few people are going to have a more in-depth understanding of than these two. They have long histories that I'm not going to go into in any detail because they're going to introduce themselves to you. But I'm very proud to have them as part of the Open UK team, and I'm sure you're going to enjoy this talk just as much as me.
Hi everyone, welcome to this State of Open subset talk. My name is Hannah Foxwell. I'm a product director at Sneak, and this is Adrian. Adrian, you want to introduce yourself?
Hi there, I'm Adrian. I work for a company called ChainGuard, and we do supply chain security, and I'm a technical community advocate, which is a fancy way of saying DevRel.
Awesome. So we're here. I'm here as an Open UK ambassador. Adrian's here as a Open UK award winner. I want to say, is that how we refer to you?
2023 honours list.
Oh, okay, awesome. He's an influencer in the world of open source here in the UK. And so what I wanted to do before we get into our talk today, which is about getting started with container security, I just wanted to share a bit about us, really. So Adrian, like you've taken a very sort of similar meandering career path to me in terms of how we both ended up working in container security. So just tell us a little bit about how you ended up doing what you're doing today.
Yeah, that's a good question, and it is a long and circuitous journey. So 10 years ago, I guess, slightly under, because we just had a Docker 10-year anniversary. I started writing a book on Docker, I guess, 2014, 2015 maybe. Or maybe it came out 2015. And part of that book, there was a chapter on Docker security towards the end. And that actually got pulled out into a separate book. And that became quite popular. And I was asked to do various talks and things kind of went from there, really. And yeah, it's Docker security and talking about Docker have been a large part of my career from that point.
Okay, so today we're learning about container security from literally the guy who wrote the book. Is that fair to say?
Well, I've got a very slim. It was one of those. Have you seen those Docker free books they give at conferences that are only like
whatever. It's a book. I didn't write a book. You wrote a book.
Okay.
So yeah, I mean, and I took a similar path into security to you. I was part of the DevOps community for a long time in London, and that evolved with the introduction of Docker, of Kubernetes, and the whole cloud native landscape. And I've spent the past sort of 5 or 6 years working with cloud native platform engineers and cloud native technologies. And I've recently moved to Sneak, and I've started to focus really on how security needs to play a role in that ecosystem and how we can improve the lives of developers who are wrestling with container security in part of their domain. So we're talking about security. Security is all about managing risk. So what is your favorite vulnerability, Adrian? Totally normal question.
I asked my team about this the other day, and there's like lots of suggestions from SQL injections. Somebody mentioned Heartbleed, which was I remember that one. That was quite big. Log4j obviously came up, but I'm going to choose Spectre. And I'm largely going to choose Spectre because I like the little ghost logo with holding the little branch. But Spectre was also a pretty interesting vulnerability. I don't know if you remember, but it's called Spectre because it's about speculative execution.
Okay.
So basically CPUs, to optimize things, they would go down these code paths that might not get executed, because that's why it's speculative, and run them in case they did get executed, and then you'd already have the answer, sort of thing. But sometimes in those code paths, they'd be using sensitive information that they might not have been granted access to in the regular code path. So in this speculative execution code path, if you could figure out what was in that code path by like side channel attacks, like timing to figure out if things are in cache, then you could access information that you shouldn't have access to. So it was a really crazy vulnerability. And one of the strangest things was, if you were doing things securely, as in you had these checks to make sure you couldn't access these things, you might have been less secure. So actually adding security made you less security, which was crazy. But anyway, what was your favourite vulnerability, Hannah?
My favourite vulnerability. Am I allowed to have two? So my favourite vulnerabilities do not have fancy names or cute little ghost logos, but basically what like my first sort of 0-day experience was when I was in my first month working at Sneak, and it was actually two high vulnerabilities that were discovered in OpenSSL, and I was new in role, and I found myself kind of at the heart of sort of 0-day preparation activity, because what was disclosed to the public the week before the vulnerabilities were published was that we were expecting a critical severity vulnerability in OpenSSL. And of course, there was a lot of sensitivity around that because of Heartbleed, because Heartbleed was a really, really far-reaching critical vulnerability that impacted a lot of OpenSSL versions and was packaged with a lot of very popular Linux distributions. So it was incredibly far-reaching and high impact. And so off the back of Heartbleed, we were like, okay, how do we get ready for this new, like Heartbleed 2.0? In the end, it wasn't a critical vulnerability when it was finally disclosed. It was downgraded to 2 high severity vulnerabilities, but it was my first experience of one of these events. And, I remember I was in my pajamas at the weekends trying to coordinate, not just how we were going to mitigate the vulnerability within our infrastructure, but also how we were going to help our customers locate and remediate against this vulnerability within their infrastructure. And so CVE 2022-3602 and CVE 2022-3786 are going to be my favourite vulnerabilities.
Okay. 3786 has a special place in your heart.
It does. It always will. And I will probably tell that story in every single talk that I do about container security, because it was absolutely the best possible learning experience for me, having moved from a more platform engineering domain to a security domain, to understand, the tools that we need and the process that we need, and to help folks prepare for these things. Jump straight into the slides and start talking about how you as a developer can get started with container security. And the reason that we're doing a sort of introductory talk is because there are loads of developers in the world, and the domain of security and the domain of containers can feel a bit daunting and a bit unfamiliar to a lot of folks. And so we wanted to do a really practical getting started talk for anybody who is unfamiliar with this space. But we also know that it's really super important. One study done by the Linux Foundation found that open source dependencies make up 70 to 90% of modern applications. And so when we're talking about security, we are quite often talking about open source as well as our own code, because we are, in one of the great things about open source is that we're kind of standing on the shoulders of giants. We don't have to start from scratch and build every single aspect of our applications. We pull in libraries, we pull in frameworks, we pull in dependencies and packages that help us get to where we're going faster. We don't have to reinvent the wheel every time. But what that means is that it means that we have a lot of very diverse packages, applications and software from lots of different sources running as part of our infrastructure. Not only that, but last year, 25,227 new CVEs, that stands for Common Vulnerabilities and Exposures, were published. That's a hell of a lot of vulnerabilities to manage. And it's only going to get more. The more software we write, the more vulnerable software will be written. And managing this manually, triaging 25,000 vulnerabilities, that is not anybody's job, and it shouldn't be anybody's job. And so making this easier and more accessible for everyone is super important to make sure that the applications that we're writing remain secure. And so the conversation about open source, the really super important role of open source in modern application development, it's not a conversation that can happen without security as a real fundamental. And so often, for security folks in organizations, open source can be seen as a huge risk. It's software that's pulled in from outside my organization. I don't know where it came from. I don't know who has access to it. And I want to understand what risk is associated to that open source software. But really, the success of security depends on the success of open source, and the success of open source depends on the success that we have with security. So I think they are really mutually beneficial to each other. When we talk about vulnerabilities as well, we have to acknowledge that there is time and effort involved in managing vulnerabilities in your applications. And a recent study by Sneak found that it takes an average of 97.8 days to fix a vulnerability. And that's an awfully long time. That's an awfully long time for anybody to have a vulnerability within their infrastructure. And so we need tools, or we need practices to get better at this, to find and remediate vulnerabilities as easily as possible. Which leads me on to kind of start talking about container security specifically, because containers are awesome. I've been part of the DevOps community for a long time now, probably over a decade, which is a little bit frightening. And I remember the sort of shift in the community through the adoption of containers. It was only 10 years ago. Docker celebrated its 10-year anniversary today. It was only 10 years ago that Docker was announced at PyCon in 2013. And since then, adoption has been, almost ubiquitous. Containers allow you to ship applications in a more portable way, immutable. It's more efficient running on your infrastructure, but it solved that age-old problem of it works on my machine, which had bogged down application teams and software delivery teams for decades. And actually, one of the recent surveys by Forrester, I think it was, has predicted that actually 85% of new applications will be shipped as containers. So, containers, especially Docker containers, containers are older than 10 years, but Docker itself came on the scene and has become almost the default way of delivering applications. And so when we think about containers, what we need to understand that, this is not a technology that's likely to go away overnight. And so getting to grips with container security is basically a fundamental skill for most application teams. So when we look at your typical container image, it's made up of layers. The base layer is usually provided by a third party. You usually select something that is useful to your needs. So you might pull something from Docker Hub, or you might select an image from a different catalog, but you're building off of a base, which gives you your operating system and other common packages that you might need to run your application. You then add anything else that your application might need at runtime. And finally, you add your app itself. And as we've discussed, your app is not just the code you've written, but it is all of the additional software libraries and packages that you've pulled in there as open source or third-party packages. Not only that, but your base image can be made up of other base images and built off of another base image and built off of another base image. So there's like this nesting relationship there. And so when we're talking about vulnerabilities in containers, it's really important to understand where the vulnerability was introduced. Was it introduced through your application and its dependencies? Was it introduced through some of the layers that you added in your Docker file when you built that container? Or was it introduced through a base image, or the base image that was your base image was built off of? And so it can get really deep really quickly. But to summarize the problem in the simplest possible terms, you've got your bit of software, and then you've got a hell of a lot of other people's software. And when we talk about container security, we are quite often focused on that, about identifying vulnerabilities in other people's software that can be remediated very simply and easily if you have the right practices in place. Because it really sucks getting hacked because of other people's software. And we know that not all open source projects are equal. Not all of them are managed and maintained as actively as others. And so, you know, the joke is that basically all modern infrastructure looks a little bit like this sort of shaky house of cards that's being held up by some poor person in Nebraska that's been thanklessly maintaining a common library since 2003. But, you know, more so than that, you know, we're also dependent on a lot of open source software that may or may not be protected in terms of the security of it. You know, when we talk about supply chain security, what we're talking about is other people's software that you've pulled into your environment, possibly as a subset of another open source project. And, you know, if a project is vulnerable or if it has been compromised, it can be quite often really difficult to detect. And that's why the conversation about supply chain security is so active right now, because we're starting to really understand the risk that some of this third party and open source software can present to our applications. And it would be remiss of me not to talk about SolarWinds. In this context, of course, the most infamous supply chain attack of all time, probably. But, you know, it has seriously shone a light on the impact and the reach that some of these supply chain attacks can have. And, you know, for those who are unfamiliar with the SolarWinds attack, what happened was the SolarWinds build servers were compromised and malicious code was able to be injected into a SolarWinds package application called Orion. That's bad enough, but actually that package, that application, was part of a monitoring product that was then deployed into the infrastructure of their customers. And so the reach of that malware, that malicious code that was injected via the build system at SolarWinds, actually ended up impacting very, very highly secured environments. What it did, it was enabled hackers to open backdoors into places where really you do not want hackers having backdoors. We're talking about the US government. We're talking about huge infrastructure companies. Nobody was really safe from this nature of attack. And, you know, this is the potential of supply chain attacks. It is the lack of control that we have around the security and the diligence of other people's software. And that can be a little bit overwhelming to think about, can't it? When you think about how on earth you, as an application team, can manage the risk of all of these different open source projects and dependencies that you're pulling in from third parties that you do not control and you do not have a good understanding of their risk profile. And so yeah, like this is a very, very active conversation in the tech community at the moment about how we tackle this problem, how we help everybody protect themselves against this type of attack, because it really isn't about if one of these attacks will happen again. It is about when, and it's about how we make sure that we are as prepared as possible for when it does happen. But even though we know that it's important, and we want to do the right thing, circumstances can quite often prevent us from doing it. A very wise friend of mine, Andy Bergin, said it best, I think, when he said the harder things are to do that don't directly impact customer value, the less likely they are to be prioritized. And I think there's a really interesting dynamic in the security space, in that actually the impact of your security improvements is often invisible. It's an absence of bad things happening, and there's no feedback, there's no reward for making those improvements. It's an absence of bad instead of like a good thing. And so we all need to think about how we can make sure that those efforts are recognized and rewarded, and that we can measure the improvements that we're making over time. Thinking specifically about container security, I've seen and spoken to a lot of different organizations about how they're managing their container security at the moment. And, there's lots of different models that you can adopt. The one on the left-hand side here, which we call one team to rule them all, is where accountability for container security is shifted all the way left, and it's delegated to the application development teams. They have complete control over what goes into their containers. They can select their own base images, they can pull from anywhere in the internet. And so what that means is high level of responsibility for the security of those images sits with developers. I've also seen organizations moving a little bit more centralized with it. So adopting a platform team approach, where a platform team is curating and hardening and validating a set of golden images, if you like, that have a seal of approval from their team as being optimized and secure and ready to use. And those are provided as a service, as a catalog to the development teams. And I've seen lots of combinations in between. And actually, a lot of the organizations that I work with, they've got such diverse technology environments, such diverse stacks that they're running, that it's usually a little bit of both. Some teams are using the model on the left, other teams are using the model on the right, but everybody has this sort of shared responsibility to make sure that what goes into your container is as secure as possible. And when I think about the security teams who are managing those golden base images, like actually making them available and integrating them into the software development lifecycle is a huge task. And it's not a task that you do manually. It's not a task that you go and knock on the door of every single application team. You need to automate that somehow. Otherwise, it's just not going to happen. It's going to be an overhead for your application teams, and it's going to be completely unmanageable for your security teams. And I used to say, we don't need DevSecOps because it's always been part of DevOps. I was one of those people. I was like, no, we've always cared about security. And it's true, the DevOps community, we always have cared about security, but actually, there is this subset of practices specifically around security, and specifically around the automation of security and embedding that into all of our pipelines and all of our software development life cycles. That means that actually maybe this DevSecOps thing is a thing. Maybe we do need it. Maybe that is a really useful conversation that we should all be having. So, getting started, these are my sort of top 3 bits of advice for anyone who is now convinced that this might be a valuable problem to solve and something that they might spend a bit of time on when they go back to work tomorrow. So the first thing and the easiest thing that you can do to get started is to go and look at the base images you're using to build your containers and optimize that for security. And Adrian's going to talk in a lot more detail about how to do that. Integrating container scanning into your software development lifecycle is quick and easy to do, and it gives you visibility of the vulnerabilities that you are running in your containers. So that is super important. And again, when you start this process, you might feel a little bit overwhelmed. There are going to be a lot of vulnerabilities. And so what I will say is don't panic. You can explore all the vulnerabilities in good time, but also you have some prioritization scores like the CVSS score that will help you focus on the right things. They include things like, is the vulnerability exploitable? Does it have a mature exploit? Is there a fix available? But also you need to add a little bit of your own context to that prioritization. So if you find a critical vulnerability in your payment system, for example, you're probably going to want to solve that before you start to focus on the medium or low vulnerabilities in your back office systems that don't have any sensitive data in them. So really context is key, as well as the severity of the vulnerability. And as I said, optimizing your base image for security is one of the quickest wins that you can have when you start on this journey. And we found this to be true in a recent event that we ran at Sneak. So every year at Sneak, we run an event called the Big Fix. And the Big Fix is a month-long event where we invite the community to join us in fixing as many vulnerabilities as possible. We run a leaderboard, we do live streams, we give out swag, it's all the things, but it's really aimed at raising awareness of security with the development population. And this year we fixed an incredible number of vulnerabilities. It was 597,589 to be exact. So almost 600,000 vulnerabilities were fixed as part of this. But actually, out of all of the vulnerabilities that we detected, what we found was that the fixes were coming primarily from containers. We found that those projects that were classified as Docker containers had a 73.3% fix ratio, which is staggering. It's absolutely staggering, but is because of the efficiency of that base image remediation. So you can, if you find a particularly old and vulnerable base image within your application stack or within your ecosystem, fixing that base image and selecting a more secure base image can fix hundreds of vulnerabilities in one simple action. And so if I was to give you any advice leaving this call today, it would be to go and check what base images you're building off of and select a more secure, more up-to-date base image. I'm now going to hand over to Adrian to get into some more of the practical side of how you might go about doing that.
Thanks, Hannah. Yes, I'm going to look more at how we can address the risks. So following very much on from what Hannah just said. And I think there's a few things we can do to try to address risk. The first thing I have here is identify vulnerabilities. And so for the purposes of this talk, we're really talking about using a security scanner such as Sneak. And then we have to think about responsibility, like where are the vulnerabilities coming from and how can you deal with them? But the major techniques for reducing risk are to reduce your dependencies. In other words, to have less software in your images and to keep your software up to date. By far the most effective way to avoid vulnerabilities is to patch or update your software. So we thought we'd change gears here. I'm going to try and do a fairly brief demo. So let's see if I can try and share this. To try and demonstrate how important choosing a base image is, as well as how important it is to reduce dependencies and keep things updated, I thought I'd take a look at the various different node images on the Docker Hub at the minute. So we're going to look at 4 images: Node Latest, Node Slim, Node Alpine, and the ChainGuard node image. So these are all pulled today, so they're all up to date, or at least up to date as of this morning and June the 9th. There will be newer versions available now. But with the Node Latest and Node Slim are both Debian based for the underlying operating system. And then we have the Node Alpine that uses the Alpine distribution, and ChainGuard actually uses our own distribution called Wolfie. Now, the major thing to notice is, of course, the difference in size. So we can see Node Latest is 951 megabytes, but Node Slim is much smaller, 244. Then we've got Alpine at 179 and the ChainGuard one at 106. The other thing to notice, though, is the created date. So we can see this ChainGuard image was created yesterday. Alpine image about 6 days ago, and these other ones about 2 weeks ago. I think 2 weeks is about as old as a latest image on a Docker Hub will get. So I'd expect to see a new version come out today or tomorrow. Okay, and then we can use Sneak to try and look into these images and the vulnerabilities a bit more. So if we run Sneak on the node latest image, again, this is quite a large image, so it'll take a moment. And it contains, because it's the full Debian distribution effectively, it contains a bunch of utilities and so on from the Debian operating system. Yep, and there we see what Sneak's telling us now is it found 409 dependencies, so that's effectively 409 different packages in the image. And out of those, it found 240 issues or vulnerabilities effectively. And if I scroll up, you can see a few of these. So this is from ImageMagick. What else we got? Curl. So both Curl and ImageMagick are in this image, but both Curl and ImageMagick are unlikely to be used by your node application. So there's a good question about why are they in there in the first place? And that's exactly why we have images like Node Slim. So if we run the same test on Node Slim, I'm hoping what we find is there's less dependencies, and possibly, yeah. So there we see there's only 97 dependencies. So I think that's roughly a quarter of the dependencies of the latest image. And because there's less dependencies, there's less issues. So there's only 49 issues there. So just by changing from Debian, from Node Latest to Node Slim, we've been able to cut the number of issues significantly. And in the majority of cases, I think you'll find that making this change will not have any effect on the application. So if you were to make this change today, you'd probably just be cutting down vulnerabilities and not impacting your ability to deploy software. And also, if we look at the vulnerabilities, we can see this one's in libSSL. So, there's a reasonable chance that libSSL will be linked against Node, I would think. So that possibly is a relevant vulnerability. If you scroll up, you'll probably find things that may be less relevant, like stuff in Bash or GPG, for example. And then we can take it even further, though. So Alpine is a really cut down Linux distribution. So there's even less in the underlying image. And you can see there's only 17 dependencies compared to the 90 odd, or 97 was it, in the Debian Slim image. And because of that, there's only one issue in this image. So we've been able to go down from 200 odd issues to one issue, just by changing the tag we're using. There is a few other things to mention. I am saying there is less in this image. Possibly there's stuff in like the Debian image that you need, or you use perhaps in development. So if it's something that you use in development, like curl, what you can do is have a different image for development than you do in production. If it is something that's needed by your application, though, what you can do is use a slimmer image and add just that package in, so you're not pulling in stuff that you don't need. And then we can look at the chain guide image. There is a slight wrinkle here. If only I had a contact at Sneak that could help me here. It does say at the bottom we don't have vulnerability information for Wolfie, and that's because Sneak is currently working on adding support for Wolfie Linux that we use in our chain guide images.
Yeah, I'll have to go and speak to the product manager for that. Oh no, wait, that's me. We are working on support for Wolfie. It's coming soon. But yeah, as Adrian said, you can use other tools to test your Wolfie images if you're interested in Wolfie at the moment.
Yep, and we'll do just that. So there's gripe, and the point I want to make here is that the chain guide image ends up with 0 vulnerabilities. It has a roughly similar number of dependencies as the Alpine one. But what I find really interesting here is this one issue in the Alpine one. If we look at it, and this is like the most up-to-date image on the Docker Hub as of this morning. But it says, Sneak tells me it's actually been fixed in version 3.11-R0 of this SSL client package. And so what that means is that Alpine Linux distribution have updated this package and released a version with a fix, but the Docker image that's been created doesn't yet have this newer package. So in the next few days, I would expect a new version of the Node Alpine image to be released, which does have this new package, and this vulnerability will go away. And the point that I'm trying to make, I guess I should stop sharing here, and I'll share the slides for a moment. So going back to the slides, the point that I want to make is that in your applications and in your containers, it is possible to get down to 0 known vulnerabilities. And that's exactly what we did with the ChainGuard containers. And the way you do it is to be aggressive about reducing your dependencies. So that means smaller base images. But also it means in your code, in your application, don't pull in libraries like Python libraries, Java libraries, Node libraries for a single function call if you can avoid it. Try not to bloat your applications beyond what is necessary. And the other thing is keep everything up to date. And I realize keeping stuff up to date is easier said than done because when you update things, something breaks. But that's why you also need tests, right? The people that get hacked most often are the people that are running 2-year-old version of a database like Mongo or something, and they've never even configured it properly. So what you have to do to stay secure and stay on or known vulnerabilities, I should say, is you have to continuously update and continuously test and continuously update and continuously test in a never-ending circle. And that's how you get to 0 vulnerabilities.
Yeah, thank you for that. And as I said, we're working on supporting Wolfie images over here at Sneak. But yeah, I think what I was actually going to do next, Adrian, is just sort of ask you for any sort of practical tips. So I imagine we've got some folks who are listening today who have no experience of managing base images. They're focused on just writing code, building applications, but also maybe don't have the benefit of a subject matter expert they can go and ask for advice. What would you advise they go and do first thing tomorrow to check on their container security?
So I think it's mainly about following best practices. I actually did a search recently, and a few blogs on Sneak came up, to be honest. So there are blogs on stuff like Python and Node that you can go and look at on the Sneak blog, and best practices for writing containers for those. Beyond that, one other really nice tool is Docker init. So Docker recently added an init command, and if you do like Docker init, it'll create a new project for like Python or Node or Go, and it'll create a Docker file with the best practices already inside it. So I think that's a really nice way to get started. Beyond that, try these security tools like Sneak, and other ones are also available, and see where you get with those. And of course, see if you can use smaller base images. If you can just change that, from Node latest to the ChainGuard image or to Alpine image or to a Slim even, then that can potentially be quite a big gain for little work.
Yeah, and I think what we're going to do when this talk goes out is we're going to share some of our favorite resources for getting started as well. So those blog posts you just mentioned, we can share all of those so that you can actually take that away, follow up, and learn a little bit more on your own time. The other thing I wanted to talk about is almost the other end of the spectrum. So it's other than the application developer who doesn't quite know how to get started, what about the security folks who are potentially, outnumbered in their organizations by hundreds, if not thousands of developers, and who have to somehow navigate the risk and prioritize their focus to manage vulnerabilities across a very diverse landscape of applications, and far too many people that you can have that one-on-one conversation to ask them to change something. What advice would you give that security person?
Yeah, well, I think they've got a hard job as the first thing I'd say. The next thing I think comes down to automation. So if you're in a situation like that, you're going to be looking at using tooling or buying in tooling to try and help you there. And on that point, I think we've probably all heard about recent advances in AI. And I think that's probably going to play a very large role in helping with security moving forward.
Yeah, absolutely. I mean, every conversation in tech at the moment seems to like converge on and how AI can be used to help solve this problem. And I think, there's two aspects of it. It's like, one, we want AI to kind of help us solve this problem, to help us navigate this complexity. But on the other hand, we're going to see a lot more efficiency in software development. You can get so much work done by using these ChatGPT and large language models, and so much faster. And so already, software is eating the world, but software is eating the world even more quickly because you can put an application together even more efficiently. And so all of this kind of automation that we have around writing software now needs to have security baked in and have security in mind. We don't want the world using ChatGPT to write insecure application code. And so that's definitely something that we're talking a lot about at Sneak at the moment, which is that aspect of it. Is like there's going to be a lot more software written, and it's going to be written with a lot less human interaction. Yeah. So how do we make sure that it's secure when it goes into production?
It's so hard. I think at this point we can no longer tell what the future is going to look like as well. It's interesting. It's both exciting and scary.
Yeah, absolutely. And so to wrap up today, I wanted to set a bit of a challenge for everyone, because what I tried to do ahead of this call is, obviously ChainGuard have got the super cute little octopus logo, and at Sneak we're a dog, and so I tried to get DALL-E to just create me an image. This should be easy, a purple octopus with a Doberman. And oh my God, like the AI has struggled with this. And so I haven't been able to find the right prompt to prevent my dog having tentacles, to get these. All right, let me see what window I'm going to share. I'm going to share a little sneak peek of some of the horrors that I've managed to create here. So this is apparently the best that DALL-E can do. I did try squid instead of octopus. That didn't seem to help. This one down here, it has a hat on. I didn't ask for a squid in a hat, and I certainly didn't ask for a murderous squid in a hat. But yeah, we have all kinds of horrors in here, and I don't know why. I don't know why the dogs so frequently have tentacles when I say specifically the dog does not have tentacles.
Do you know, I think it's the squid has dog features, not that the dog has tentacles.
Maybe. So anyway, this is where AI has failed me this week. And so what we wanted to do, for anyone who's listening and is still staying with us and stuck with us to the very end, if you can create a better or actually better / more horrifying image of the Sneak Doberman alongside the ChainGuard octopus, then please send it over to us. And and we'll pick our favorite and we'll send you a lovely little swag bag. So I'm really looking forward to receiving some of those, because honestly, it was pretty horrific and frightening what DALL-E created for me on that respect this week.
Okay, thank you very much, Hannah.
Thank you everybody for tuning in, and we are going to be available online to answer questions. So look forward to hearing from you. Thanks.
Bye all.
Thanks very much, Hannah and Adrian. I really appreciate your talk. It's really interesting to see more on security. And of course, security is really high up our agenda. In July, we're going to have our second summer of open source software security. You try saying that. It's a really difficult one. And at State of OpenCon in the spring, we are going to have our second State of OpenCon with a very, very key track for us on security. So we look forward to seeing you at that talk.